All right, whole new unit, okay? Now this is probably the most important unit that we'll do this year because it is very, very, very excruciatingly vital for grade 11 and grade 12. Okay, so we are starting the new unit, which is called polynomials. Now, I want you to look at this page. Everything that is circled right now, it is a polynomial. The ones that are not circled are not polynomials. Can you deduce from that information right there why those ones are not polynomials? Like, why are they so different than the other ones? So let's start pointing out some differences. Because all the other ones that did not get into the circle club, they fail as polynomials. They're polynomial failures. But why did they fail? Okay, so if I had a multiple choice, number one, I had A, B, C, and D, and I said, which one is not a polynomial? Could you find it? So this one, I'm telling you all the right answers. What is the difference? Yeah. Division by a variable. You cannot have a variable on the bottom. So that's why this one fails, right? This one fails. Do any other ones fail because of that same reason? Yeah, this is the same thing as 3 over x squared, is it not? So that one fails, and this one fails, because that's the same thing as 6 over x squared, right? So you're right. Anything that has a variable on the bottom is not a polynomial. But the other ones are still surviving. They do not have exponents, or sorry, powers or variables on the bottom. Winston? Yes. Thank you. Okay, come on. So a good comparison, to me, I would go, why does this one get to be in the club and this one doesn't? And why does this one get to be in the club and this one doesn't? There are two people that know what's going on here. What, you got a question? Yep. It's not a variable. Tricky, eh? Yep. Okay, does anybody know another way to write this? We did a whole unit on it. X to the 1/2. So this is the same thing as 3x to the 1/2 plus 5, right? Yes? We did a whole unit on it, right? So we should be. Now, that's the other thing that makes it fail. You cannot have, so we can't have variables on the bottom. Which is also called the denominator, right? And number two, the exponents on variables must be whole numbers. 0, 1, 2, dot, dot, dot. So, with this, we can see why this one fails. What about root 6x? This is the same thing as root 6 times root x, right? Which is the same thing as root 6 times x to the 1/2. So you can see why that one fails. So we got rid of all of them? My only question is, how come this one gets to have a square root and this one gets to have a square root?
Because it's not it has
Yeah, this is just a coefficient. The x is not being affected, is it? So the x doesn't have a square root over it. Okay? Right? See, the x doesn't have a square root over it. This one it does. Of course, this one does, and so does this one. Yeah, these are all very sneaky. Students will say, this is not a polynomial. I'll go, why? Because it's got a square root. No, 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 no. It's got a square root over the 3. That's fine. Okay? Yeah, it's subtle. Math is extremely subtle. They just shorten that line by just a little bit, and it means totally different question. Okay? Welcome to high school. Now, so we know for sure why these are not polynomials, but we also want to add another example, like x to the 1/2 plus 5 is also not a polynomial, because we already stated on the last page, you cannot have variables in the bottom, and you cannot have exponents that are anything but whole numbers. Okay? So you can see why this is a polynomial. No negative exponents and no fractional exponents. So we're just going to go through and we're just going to learn some of the basics today. It's a nice day. You'll all be able to get your homework done in class, and we'll get our trig test back before you go. Okay? So classifying polynomials. Now, you can just, let's talk about a term. Like, how do I know if there's like 5 terms, or like when you look at a sentence, how do you know that there's 5 words in a sentence? Spaces. So words are separated by spaces. That's why you know. Words are the same thing as terms. Okay? They're equivalent. But when you have a bunch of terms together, they're not separated by a space. They're separated by a plus or minus. Okay? So terms are, they are separated by a plus or minus. So we can also call them, like, we don't have specific names for 3-word sentences or 2-word sentences or 1-word sentences. But in mathematics, we do. For like a 1-word sentence, we call that a monomial. Okay, mono meaning 1. So it's 1 term. We don't say word, we say term. So examples would be like 2x cubed, 16x, or just 5. Now, why is 5 a polynomial? Like all the other ones have x's. This one doesn't have an x, but it actually does have an x. Okay? It would be 5x to the 0, which is the same thing as 5 times 1, right? So that goes back to this joke where it says I'm a polynomial in disguise, That's because it's actually 23x to the 0. So it's actually a polynomial. It'd be specifically a monomial. Okay? So you probably never thought of a number as a polynomial before, but it is as well. A binomial would be like a sentence with two words or two terms. So an example would be like 2x plus 3 or 5x squared plus 2x. Right? Just two terms. Why? Doesn't matter how long the term is. If it's separated by a plus or minus, and there's two of them, it's called a binomial. A trinomial, three terms. So like 4x squared plus 5x plus 2. That is a trinomial. Okay. I'm sure you all have fond memories of these. Algebra tiles. Now, the goal for me and for the next 2 years, especially this year, we're going to wean you off of algebra tiles. So we're not going to spend a lot of time with them, but you'd still have to know they exist. The grade 9 achievement exam, unless they've changed it, always has one algebra tile question on it. Okay? So that's why it's part of the curriculum. But the diploma doesn't have any algebra tiles on it. Now, let's just talk about it. What was that black square called? X squared. How about the white one? Negative x squared. Okay? How about that bar? What was that called? X. This is negative x and 1 and negative 1. So let's just identify this. What would this polynomial represent? What is it? Negative x squared plus 3x plus 1. How about this one? 2x squared, no, 3x squared. Jeez. 3x squared plus 1x. Well, let's do it as a algebraic expression first, and then we'll, so plus 1x minus 1x plus 2 minus 1. Now these two, see we have a, remember the positive cowboy with one bullet meets a negative cowboy with one bullet, right? They both die. Or they both live. Touche. So 3x, and then 2 minus 1, positive 2, negative 1, positive 1. So just 3x squared plus 1. Okay? Now, let's get to adding and subtracting polynomials. This should be a review, but still a lot of questions in the last class, so maybe we'll come up with a few things. Now, whenever you have brackets, now remember when you add and subtract in polynomials, when you add and subtract words, the words have to be identical, or else you can't add them together. Like identical except for the coefficient in the front. Because if you have 3 of those and 2 of those, you would have 5 of them, as long as they are identical words. Now, a good habit to do is always to get rid of your brackets. So this would be like 3m squared plus 2m plus 7. And see this plus sign? It gets what we call distributed to all of these. So that would be plus m plus 4m squared plus 9. Now, if you're, I used to give these to my students and I'd have like 20 things and they had to combine like terms, right? Keeping organized is one of the probably biggest barriers that students have to do these. So one way to keep organized is put specific shapes or colors or underline or whatever around the ones that are the same. So do you see I got a 3m squared and a positive 4m squared. And the trick is to always put the sign that's in front of it with it. Now, if you, and I want you to remember your cowboy story, okay? If you had a positive cowboy with 3 bullets and it meets a positive cowboy with 4, it would be a positive cowboy with 7 bullets, okay? And that's my m squared. So you don't add m squared to m squared, or you don't do anything with the exponent. That's not 7m to the 4. We do not add exponents when we add like terms. That gets confused, right? Now, the next group would be, maybe we're going to do them with circles, right? 2m and m. Okay, now that's the same thing as 1m, right? So 2m and 3m, 2m and 1m, 3m. And then I always make sure to cross them out. Now there's not many here, right? It's not like it's a huge organizational nightmare. But when there's 20 of them, and you don't, and if you cross them out and then later you see an m squared there, it's easy to just add it in. Or you're going to go, did I already do that one? So you have 2 chances. You can say, yeah, I probably did, and then finish the question. Or start all over again if it's a test question, because you don't want to give up that mark. So crossing them out, doing something to say, yeah, I've been there, done that. Okay, and I got a positive cowboy with 7 bullets meets a positive cowboy with 9 bullets. I would have a positive cowboy with 16 bullets, right? Okay, so that's pretty easy. Let's go to subtracting. Now subtracting, this part here, the number 1 mistake in math. It will haunt you all the way through high school, and it will haunt you all the way through university. And there will still be students that do this wrong, okay? And it costs them a lot of marks. Now, do you see how we took that plus? Because basically there's a plus here, and you can go to everybody, which doesn't change it, does it? Because when you do that, that's multiplication. When you multiply this, you have to multiply all of these in too. So we would have 4m squared plus 3m plus 2. You see that? Now, that negative gets multiplied to everybody. So negative times 2m is negative 2m squared. Do you see how now we have a negative times a negative 1, which would be positive 1m. Okay, and this very last one, a negative times a positive 3 would be negative 3. I know students that skip that step a lot so they can get to the wrong answer faster. Okay, so if you're doing it to be efficient, if you really think about it, that's the most inefficiency you could possibly have. Because if you go through all that, skip a step, and get the wrong answer, you get 0 for that question. If you didn't even try, you get 0. So look at which is the most inefficient. So if you're going to take the time to do it right, or you will probably get it wrong. How many times students get the wrong answer? I'm like, where's your work? I did it in my head. Okay, not well, because look at your answer. So make sure you're doing this step. Then we will do our cowboy story. So if we have a positive 4m and a negative 2m, that would be a positive cowboy with 4, negative with 2, positive cowboy with 2 bullets, and then put your m squared, and then cross them out. Next, 3m and 1m is 4m And then you have 2, I can cross those out, positive 2 and negative 3, negative 1. Now B can be confusing because it says subtract those two. Well, there's actually a subtraction sign out here. That's what that means. So you'll want to rewrite this as negative 4m minus 5m plus 3. That's just the top, right? Now, what would be next after this? So that would be plus 3m squared minus 4m plus 8. Okay, so if I have a negative 4m squared meets a positive 3m squared, it will be negative 1m squared. If I have a negative 5m meets a negative 4m, that would be negative 9m. And if I have a positive 3 meets a positive 8, positive 11. Here, well, since it's minus, it says subtract. No, it's a good question. If it didn't say subtract, I wouldn't.
The bar underneath of
That's like give me the answer underneath. You know how you used to do in like grade 2? You would go 4 minus 3, right? No, this is the same question. It really is. Okay? But now we got all these, this polynomial, this sentence minus a sentence. Okay? And you were doing a sentence minus a sentence before. They were just one word ones. Okay? Yep. No. But it's a good habit. It's just like, do I need a positive in front of some numbers, like the first number? I put it. So, okay. So this one here, let's just write it out. 2x squared minus 3x plus 6. What would be next? Negative 3x squared plus 2x plus 6x squared minus 5x. Okay, so again, we got to keep this straight. I got a 2x squared meets with a negative 3x squared. What's that? Negative 1x squared meets with 6x squared, 5x squared. Cross them out. Okay, then I have a negative 3x meets a 2x, a positive 2x. Negative 1x, a negative 1x meets a negative 5x, negative 6x. And we're done. Plus 6, yes. There's that 6. Look at him. So quiet. Sitting in the corner there all by himself. Okay. Sometimes we miss him, so make sure you do a scope after. Make sure everybody got accounted for. Because 6 didn't play well with the others, so he was all by himself. Okay. Let's do multiplying monomials. Now, when you multiply monomials, which we have done already, you have to be very specific about what you do. The first thing we do is no, that's not distribution actually. How many terms is this, by the way? One, 2, or 3? 1. Those people that say it's 2, what's your reasoning? Is there any pluses or minuses in there? No. This is like one word that's been kind of split up, and now we're going to put it back together. But the first thing you should do is always multiply coefficients. Okay? It's okay. He's got the hiccups. It's not like you killed somebody. Now, if you have x and y and x squared and y, put 1s there. Now, what do we do with the variable or the powers? Add exponents. Remember, this messes with their heads, right? Because we're like, I have people that on the last test, they were adding the 3 and the 7 together. You can see why that is not going to go well. Okay? And why are they thinking that way? They never thought that way last year. It's because now they have this new learning that's conflicting, and they haven't quite sorted it out yet. Or they made a mistake, right? We all do that. No matter how well you know it, sometimes you just screw up, right? That's life. So you got to make sure, keep it straight. Multiply those 2. Those are 3 times 7. That's 21. And then I would have x to the 3, y to the 2. Okay? Now the next one is the same question. I just have to multiply fractions together. So I multiply my tops. 2 times 9 is 18 over 3. And that would be x to the x to the 2. Why? Because there's 1s there, and when you multiply powers with the same base, you add exponents. You might have heard me say that a couple times. So that is the same thing as 6x squared. Okay, so this is a lot of review at this point. Now, this one here. Instead of multiplying these 2, we will divide. So 34 divided by 17 is 2. And all of these we will subtract exponents of like bases, right? Only if the bases are the same are we going to do that. Put your 1s down or you will make a mistake. So that would be x to the 3, y to the 0, which is the same thing as 2x 3 times 1, which is 2x cubed, right? Right. But not or. They don't actually cancel each other out. They make a 1. That's what they do. Okay, we don't have to do the second one. We get that, right? Okay, now we're starting to mix things up with the distributive property. Now, the distributive property is very similar to the negative multiplied in. Instead of multiplying a negative in, we will multiply 3x in. So this is like doing 2 multiplication questions. So 3x times 2x is 6x squared, right? Add the exponents. And then 3x times negative 5, 15x, good. Now, most often, 99% of the time, you will see the number that's multiplying will be in the front. But it doesn't have to be. It can be in the back, and these two are going to multiply that. So the answer to this would be 10x squared minus 5x. Okay. We'll just go down to division now. Now division can be a little bit of a tricky... Am I going too quick for you? Well, do you say shit after? No, you won't, because you're going to make notes to yourself. You're going to put SS right on there. Okay, trust me, it works. Yep. And this would be a 2 over 1. Okay? Now the next one, these are a little bit more complicated. You have to look at this and this. So this is the same thing as 6x cubed over 2x minus 2x over 2x. So you can split that denominator up. So in other words, what I'm trying to say is a plus b plus c all over 2 is the same thing as a over 2 plus b over 2 plus c over 2. But weird enough, and this is what you have to know, that 2 over a plus b plus c, the best you can do is 2 over a plus b plus c. You cannot go 2 over a plus 2 over b plus 2 over c. So with this convenience, I can separate it, and then I would get two kind of questions. Because what would this equal? No. 3x squared minus 1. Okay? So you can separate it like that if it makes it easier for you, or you can just start doing them like this. Yes?
On the first example, where did the y come from? The 2y?
It's,
Then that.
those are all x's.
Okay.
Okay, so you can just do it this. What's 20a cubed divided by 2a? Then a squared. And then I can do the other one. So negative 4a over 2a. Negative 2. Making sense? Okay. Let's... Yep. Because there's a 1 there. And we subtract the exponents. Well, no, because it's a to the 1, a to the 1, which is a to the 0, which is 1. Okay. Let's do this example. 25x squared minus 10x, and it says that the length is 5x. Find the width. What is the formula that we would be using? So a equals LW. I want to find W, so I will divide both sides by L. So A over L equals W. A is 25x squared minus 10x. L is 5x. So you can see why it's just like the above question. So what would be the answer to that? 5x minus 2. Oh yeah, sorry, 5x minus 2. Because there's a 1 here. Okay, now this one here, what's the volume of this tank? Okay, I want you to see if you can do it underneath here, because I want to do another example over here. I need this real estate there. Okay, so volume equals length times width times height, right? Always put the binomials, put them last. It's easier. So then I'm going to go m times 2m times 4m plus 2. So volume equals, now multiply those first two together. What does this equal? 2m squared, and then I can multiply by 4m plus 2. So 2m squared times 4m would be 2 times 4 cubed. Very good. Plus plus 4. Good. Okay. So this is example 3. So here's your question. 3x squared y squared. So it's solve. Write that first. Solve 3x squared y squared plus 2x squared y plus 3x if x equals 5 and y equals -1. Three x squared y squared plus 2x squared y plus 3x if x equals 5 and y equals -1. Okay, try it out in your calculator. See if you can get it. What's that? With. Go ahead. This is pretty easy to do without. But maybe that's just me talking. I'll show you how to do it without. But what are you getting? Nope. Mm-hmm.
80.
Nope. 40, yep. Anyone else get 40? You got 40? If you ever substitute without brackets, you're most likely going to get it wrong. And I'll tell you why. If they ever give you a negative number, you'll get it wrong. So here's, if you go 3 times 5 squared times -1 squared, just this one alone. See, I'll show you how to do this without a calculator. So just look here. What's 5 squared? 25 times 3. 75 times 1. So, no, times 1. Now, if you don't square the -1 in brackets, you'll get the answer -75 right there. Okay? You always have to substitute in brackets. Okay, and then this is 2 times 5 squared times -1 plus 3 times 5. Now this, 5 squared times 2 is 50 times -1 is -50 and then plus 15. So 75 minus 50 is 25. 25 plus 15 is 40. Okay, so don't think since you have your calculator with you, it's going to save you. If you don't know how to put the information in there correctly, you're not going to be successful. Okay. So you can look at the next page and start. Yep. See the whole page. It's going to take you about 10 minutes. The answers are on the page that follow that.